Hey guys, sorry these notes are up late, but hopefully um, easy enough for you guys to get. Today we talk about angle relationships with parallel lines and a transversal. So first I'll go through some definitions, and then we'll kind of use these in practice. If we look here, line L and line M are parallel, and we can tell they're parallel because I have my marking on the lines, right? The arrow marking. So you always have to have your marking on the lines before you can assume that two lines are parallel. Don't assume that these two lines are parallel until you see your marking. And marking can look like that, or it can be like a filled in triangle. Did a bad job filling that in, but well, you guys get the point. Like this would be what a filled in triangle looks like. Okay, line K over here is what we're going to call a transversal. We'll talk about those definitions in a second. And when we have this situation, two parallel lines and a transversal cutting across them, I create these 8 angles. Okay, and we're gonna examine the relationship and what we call angle pairs within those 8 angles. Okay, um, so parallel lines, of course, lines that do not intersect, they have the same slopes, and we continue them forever in either direction. They will never ever intersect. They'll never touch. A transversal, very simply, is any line that cuts across two other lines. It's at least two other lines. You could cut across more, but at a minimum, any line that cuts across two lines. So we see up here that K cuts across L and M, so that is considered a transversal. The next 5 that we have here, these are going to talk about two angles in relationship with each other. So if you have alternate angles, when we say alternate, we're talking about where it is relative to our transversal. So our transversal is this diagonal line. If I have alternate angles, one's going to be on the right side, one's going to be on the left side of the transversal. So, for example, 2 and 3 are on alternate sides of the transversal. Okay, you could think left and right, or you could think above and below. I could say angle 6 is above the transversal, and angle 1 is below the transversal. So they're on alternate sides of the transversal. Same side. That's the same idea, except now we're talking on the same side. So 1 and 3 are both below the transversal. They're on the same side. Okay, 4 and 6 are both above, or I could also think they're both to the right of the transversal, so they are same side angles. Interior, we're talking about anything that's inside the two parallel lines. So 3, 4, 5, and 6 are all interior angles. Exterior, any angles outside of the two parallel lines. So that would be angles that are outside here. So 1, 2, 7, and 8 are all exterior angles. Corresponding angles. This is where you have one interior and one exterior angle, so one inside and one outside, but they lie in the same relative position. So if I look at like angle 2 and angle 6, those are both lying in the same position, but 6 is interior, 2 is exterior. Okay, and I'll talk a little more about that at the bottom of the page here. Okay, so an important note, we're going to go over 5 angle relationships and I'm sorry, 5 angle pairs. So angle pair is like the name for the two angles, and the relationship that we talk about is only going to be true if I do have parallel lines. So as soon as you see those parallel markings, you can assume that the following relationships of angle pairs will hold true. So let's look at alternate interior angles. Okay, so now I'm combining a couple of these definitions. Alternate interior angles. Well, alternate means I need one on the inside and one on the outside. I'm sorry, alternate means I need one on either side of the transversal, and then interior means they have to be inside of the parallel line. So angle 4, angle 5 are alternate interior angles. We have another pair of alternate interior angles, angle 3 and angle 6. Okay, and the relationship between alternate interior angles when we have parallel lines is that they are congruent. And we never want to trust the picture. We want to be able to prove something, but you can tell like angle 4 here looks the same size as angle 5, and that's because they are congruent. Okay, alternate exterior angles. So now I'm talking about angles on the exterior, so above and below my parallel lines. And alternate means one on either side of my transversal. So angle 2 and angle 7 are alternate exterior. Angle 1 and angle 8 are alternate exterior angles. So 2 and 7. And angle 1 and angle 8. These are also going to be congruent to each other. Next, we'll talk about corresponding. By the way, if you need to pause at any point, please do that. And please pause so that you can see the screen and copy notes down. I'm trying to beat my 15-minute timer here. Corresponding angles. So pick any one of your angles. So I'm going to pick angle 4. Let's find a corresponding angle. What you want to do is find the angle that lies in the same relative position, but on the other parallel line. So this angle 4 is made up between the transversal and line L. If I slide this down to the next parallel line, I'll see the angle in that position is angle 8. Right? It's like of the 4 angles, it's the bottom right one. Well, when I look at parallel line M, the bottom right one is angle 8. So 4 and 8 are corresponding. Okay. Same thing, I could look at angle 7 here. When I slide that up to my other parallel line, I get to angle 3. So those are corresponding. So angle 3 and angle 7. I also have angle 1 and angle 5 are corresponding. Angle 2 and angle 6 are corresponding. And their relationship is also congruent. It's like you're copying and pasting that angle to the other parallel line. Next, we'll talk about same side. So same side interior angles. These are also called consecutive interior. I try to use same side, but you will see consecutive being used. So same side interior. Okay, pick any interior angle. So let's pick angle 4. That's on the right side of my transversal. Well, I have 3 other interior angles, 3, 5, and 6. Which one's on the same side? Angle 6 is on the same side. So angle 4 and 6 are same side interior. Also angle, what was the other one? 3 and 5. Okay, these are going to be supplementary, which means add to 180, just to refresh you, 180 degrees. Same side exterior angles. Now I'm looking at angle 1, 2, 7, and 8 because they're exterior, they're outside my parallel lines. Look for pairs of those that are on the same side of your transversal. So angle 2 and angle 8 are same side exterior, 1 and 7 are same side exterior. These will also be supplementary. Just trying to match up the color of my font, but you guys will be okay. Okay, so now let's, I won't go over this in too much detail. One thing I want you to remember is that if you are same side Interior is same side. Exterior, you are supplementary. So anything that starts with an S is supplementary. The other ones are congruent. Corresponding, we get confused by a lot. Just remember that starts with a C. Congruent starts with a C. Okay, 3 examples real quick here. So in the figure, the measure of angle 2 equals 75. The first thing you need to do is write that in your diagram. So remember our old relationships still apply also. So vertical angles. So if I look, angle 2 and 7 are vertical angles, right? Also, 2 and 3 form a linear pair. So I know that 75 plus the measure of angle 3 has to equal 180, right? 2 and 3 form a linear pair. When I do this math, I'm going to get measure of angle 3 equals 105. And 3 and 1 are vertical angles. I have an X, right? 1, 2, 3, and 4. I create an X there between line P and line M. So 105 is angle 1. Next, I can use the relationships that we just talked about. So angle 3 and angle 5 are alternate interior angles. They will be congruent. Angle 5 and angle 7 are vertical angles. They will be congruent. Let's see, I can use a different relationship. Angle 2 and angle 8 are alternate exterior angles. They will be congruent. I could do vertical between 8 and 6, but let's do something different. Let's do corresponding. 2 and 6 are corresponding. So that'll be 75 there. So you can see when you have this scenario, 2 parallel lines and a transversal, there's only 2 different angle measures. You just need to fill in what they are. Okay. Okay. In the figure, measure of angle 3 is 102 degrees. I call these tic-tac-toe problems. A little more complicated. Now I have 2 sets of parallel lines. So if I look at line M and N, these 2 horizontal ones, I have 2 different transversals, okay? You can just look at one transversal at a time if you want to. So let's look at line M and line N as my parallel lines, and let's call line P my transversal. So angle 3 is 102 degrees. I know that between 1, 2, 3, 4, 5, 6, 7, and 8, I have 2 different angle measures. Okay, so let's fill these in. Angle 1 is going to be 102 because it's vertical with 3. 1 and 5 are corresponding. 5 and 7 are vertical. Now, angle 1 and 2 are a linear pair, so they have to combine to be 180. 2 and 4 are vertical. 4 and 8 are corresponding. 8 and 6 are a linear pair. Okay, so I'm not going to fill in A through F. I'll just fill them all in on this table. Now let's look at something a little different. Let's think of P and Q as my parallel lines, right? P and Q are parallel lines. And let's think of line M as my transversal. So let's ignore N right now. So 1 and 9, I'm sorry, 2 and 10 are corresponding, right? 10 and 12 are vertical. 1 and 9 are corresponding. 9 and 11 are vertical. Okay. Now let's think about M and N as my parallel lines and Q is my transversal. So now the same relationship applies. 11 and 15 are corresponding. 15 and 13 are vertical. And then 14 corresponding. 10 and 16 are alternate exterior. So you have same thing's going to apply. You have all the same measures, only 2 different angle measures. Guys, I'm going to do this next example as a different video.